this is a second infinite geometric series activity where we want to see this what's happening to the sum as we add more terms to this infinite series that is decreasing. So there's an animation that goes with this, so you can always go to that to see what this looks like. But let's start here. So we're going to start with an area of 1, and the Tn, the first term, is going to be 1/4. Okay, so we're shading 1/4 of this triangle. And so the total sum is going to be 1/4. I'm going to then shade this portion here. So this is 1/4 of the 1/4 fraction. So this is 1/4 of 1/4, which means it's going to be 1/16. So this ends up being 5/16 when I use a common denominator. So I can just, I want to continue doing this and see what happens to this sum. And we want to know, we know that this is going to converge because this is an infinite geometric series where r is equal to 1/4. We're starting with 1/4. So we could actually use the formula, but I want you to do this for a number of terms and see if you can predict the sum. And so what's happened to Tn as n gets large? Well, we know that this is tending towards ... 0. So Tn, okay, and we should use a limit. The limit as n approaches infinity, the Tn is going to approach 0. And the values of Sn should start converging to some finite sum, because we know that infinite geometric series, and again, not all series do this, but infinite geometric series do have finite sum. And then we can use that. We can see based on the table what's happening to this column here, the Sn column, and we can confirm what we see using the S formula. And so I'll just put the formula over here. The infinite sum is equal to A over 1 minus R, okay, where A in this case was 1/4. So do that, go ahead and do that and answer those questions, and we can do the same process here. So this one has an animation that goes with it. There's a link. This one I don't think has an animation, but we can do the same thing. We're going to start with 1/3. Okay, we're going to start with A equals 1. We're going to start with 1/3, and then we're going to see what happens as we add up all these terms. Okay, and we can do the same thing. We can do the same thing with R is equal to 1/5, and so on and so on. Okay, so I think these ones here we really should start with 1/3 and 1/5 and do the geometric sum and see if you can come up with some generalization for this.